All right, this is a quick discussion on parallel loops and multi-threading in Labview. The nice thing about Labview is everything's inherently multi-threaded. If we just drop a bunch of functions down on the block diagram, then those things will happen in parallel. So I can come up with, if I put things in different loops, then I can actually have different loops running in parallel. So I'll have an example here. We'll run a bunch of while loops at the same time so that we can simulate. We'll gather some data. In fact, let's do this. I'll use the random number generator, but obviously the data could come from anywhere. And so if we had some routines in our first loop here that would generate a bunch of data, and for example, I could publish that to the screen, call that data, and again, I'll want to create a stop button. And then, for the sake of having our VI play nicely with others, I'll put a delay in here and give it a delay of 5 milliseconds. And now I can use local variables to pass data from one loop to the next. We'll see this isn't necessarily the best way to do this, but when we get into to queues and synchronization routines in the future, we'll see how to do that a little bit better. But I could take the data, for example, and I could, I don't know, maybe creating a rolling average. So if I were to add a shift register, and I could, for example, build array, maybe tack the data onto the end of that array. Oops, change this to be a constant. Empty array over here for initialization, and I could create another indicator. Now for my stop button, I want one stop button that stops all of these, so I can create a local variable on my stop, make him be read. Again, I'm right-clicking to get these menus. I've got an error now, which is my stop button came up with a default latch, and when we have the latch conditions, Labview doesn't know how to respond to latch conditions when a local variable exists, so we can go to switch, and then should I want to reset the stop button, in fact I can do that at the beginning of the program as well. I'm going to make this a little bit bigger. I could, for example, wrap this entire thing with a flat sequence structure. And before this, I could, for example, create a local variable on the stop button and default that to false. And then let's see, I'm going to do one more loop here for my while loops. I hold down the control button, I can create a copy of a local. If I do copy paste, normally the locals will just create a new constant, and that's actually a setting in options. So we can go and change that in the configuration if you like. Again, I'm going to create a local variable of my rolling average value, and this isn't the best way to do that, and think about why that might be. Well, I'm using some timing here for to try and synchronize these loops, but the reality is that they won't necessarily all be synchronized. If my arrays get really big here, this could take longer than 5 milliseconds to do, and this loop would come out of sync with the rest if data acquisition took a long time. So I run the risk of maybe missing a bit of data or gathering the same piece of data twice. There could be all kinds of different things that could happen here. And so if I want data integrity, which should be of utmost importance for our actual programs, then I will want to take care to make sure that I pass the data in a way that I get it once and only once. And the way that we'll do that in the future is using synchronization, the queue routine specifically. So anyway, let's see. I've got most of what I want here. Let's see. Oh, rolling average. This is an array. I don't want that. I should actually do the mathematics. So let's go to math, probability and statistics, and then take the mean of this guy. And now I can do create indicator, and there's the mean. And my local variable, when I deleted him, he went away, so I can assign that to mean. It's the same as going and creating another local. And then I can, so there I get data, I got the mean value of the data, and I can drop down a chart or a graph. I'll do a chart because a chart has memory. It takes individual pieces of data. Oftentimes we'll want to use graph to have a little bit more control, but this is a nice simple example. So there's my waveform graph, and it looks like my routine is ready to run. And so if I run this guy, well, sure enough, we see our wandering. I've got auto scale on here. Turn auto scale off, then we can see that we're actually really close to 0.5. And so when you run this to start with, you'll see that, sure enough, we zoom in on 5 pretty quickly. So the point here is not necessarily to test the effectiveness of the NI random number generation routine, but instead to show that I can create parallel loops and I can pass data between those loops. And so this is a brief introduction to how to use multiple loops and do parallel programming in LabVIEW. And again, we'll want to keep in mind that there are some pretty serious timing problems with this program. And so I can't guarantee that a given piece of data won't get read twice as it cascades down this architecture, or won't get read at take careful with that. But for now, that's a brief introduction.